Good morning, everybody. Thank you very much for joining our webinar today. My name is Mark Taylor, and I'll be presenting some of the information about the British Standard. So today we're talking about the Guide to the Design of Balconies and Terraces, BS 8579. Next slide. So housekeeping. The seminar is being recorded and the recording will be distributed later on. If you have any questions, please use the Q&A function and we'll try and attend to them and answer them towards the end of the seminar. BSL will email a recording of the webinar in due course. Next slide. So as I say, my name is Mark Taylor from Allies & Morrison Architects, and about 6 or so years ago we identified the need for a new standard to cover balconies because there just seemed to be so many different opinions on the way balconies should be designed, the way they should be made, what they are, and so on and so forth. And so we started a campaign to try and work the business case for the standard, and eventually started being involved in the writing. And it looked at balconies originally, but then began to expand into the world of terraces, and started off as a kind of quite a small, succinct piece of work, and expanded into quite a large standard that it is today. So the first task was to look at definitions. We had to go through basically all the components of balconies and terraces, and just figure out, just review exactly what they are, and what people's perceptions of them were. So we're starting off with the balcony. The text says accessible external amenity platform above ground level exterior to and with direct access from a building. Now there is an existing definition of a balcony in an ISO standard, but it was felt that it needed to be fleshed out a little bit, and after much debate this is where we got to. So then the next one is an extension of the balcony, which is the enclosed balcony. This arose because there's a lot of people using different terminology for different types of balcony with some degree, greater or lesser, of enclosure. And so we use the term enclosed balcony here in the standard, which is a balcony that is protected from rain ingress by a roof or a balcony above, and walls or weather screens to the sides. This differs slightly from some people's perceptions, but it was felt there was a need for a national standard and a national line in the sand as to what an enclosed balcony is and what its function is. This is kind of explained by a diagram, which is in the next slide. No, just one other thing is that note that the envelope above a balcony is deemed rain resistant, but not part of the thermal, acoustic, fire separation or air tightness envelope of the building, and therefore an enclosed balcony is not considered in this document as a habitable room, except for assessment of escape from fire. And an enclosed balcony is sometimes referred to as a winter garden. Now this is where the discussion started, because there is a lot of debate as to where the weather line should be in an enclosed balcony. Should it be on the outside? Should it be on the inside? Where should the thermal line be? And then questions of fire, fire enclosure and fire safety arise. And so it became obvious that the nature of enclosure should probably start with safety. And therefore, there's good definitions within BS 991 and 991 and 9999. So that is the origins of the term enclosed balcony. Next slide, please. And so here's the basic explanatory diagram, which shows three types of space, one being an enclosed balcony, two being the interior space, and three being an enclosed terrace. And the difference between the balcony and the terrace is that the balcony has what is effectively exterior space below it, whereas in 3, the terrace is just simply a continuation of a terrace, but an enclosed part of that terrace. There's all sorts of provisions needed in order to design these in a way that is effective and doesn't cause nuisance, and gives rise to a good, useful exterior amenity space for the occupants of the building. So in the definitions, next slide, please. The various elements are keyed up, which, if we look at the next slide, we'll see the key and the drawing together. So just to explain this a little bit, we've got the three types of space: the enclosed balcony, the interior space, and the enclosed terrace. And if we start from the inside, working outwards, then normally between two, if we take apartments in an apartment building, there will be some form of fire separation in the horizontal structure, which is defined in BS 991 or BS 9999. And so we refer out to those standards. Moving across towards the outside, there will be the need for some sort of thermal, acoustic, and weather envelope, which will need to be openable, and it will have all the necessary performance characteristics of an external envelope. That then causes the need for thermal breaks, where the thermal envelope passes through the structure, which are coincident with the waterproofing line and will necessitate some form of fire stopping in order to prevent the spread of fire through that zone. Then we've got the balcony structure, projecting forward from that and continuing towards the outside, some form of blinds or solar control to mitigate the extremes of temperature in the enclosed space. Then a weather screen, which clearly needs to be openable and provide equal or more ventilation to the openings on the thermal, acoustic, and weather envelope line on the inside. And then some form of guarding. And you'll notice that here there's a new concept, which is that of permanent gaps for airflow. And what this does is ensure that this space is deemed an exterior space, a genuine amenity space where you can go and dry clothes, washing, do exercise, have a smoke, whatever, the sort of activities which give the occupant that break from interior space, that essential connectivity with the exterior. So some people would want to put the thermal envelope on the weather screen line. That would not fall within the provisions of the standard, and would create some form of internal room, internal space, and in terms of the standard, wouldn't be classified as a balcony. So the standard is quite clear about what is exterior space and what is interior space in terms of the thermal envelope. Note that in terms of fire, that's a different thing, because the enclosed balcony or the enclosed terrace would be an interior space, a room within a room, and therefore, because you're escaping inwards across the flat, it's not classified as external space, it's more classified as internal space. So that's the definitions for enclosed balconies. Next slide, please. We've got a few more definitions. So in this one, the block on the left would be a recessed balcony, and on the right would be an enclosed recessed balcony. So what are the differences between the projecting balconies, recessed balconies, and so on and so forth? There was a need for some nomenclature here, so we'll cover that further down. Next slide. Just a reminder that the standard relies heavily on the definitions within 9991 and 9999, which cover fire safety in buildings containing residential element and other buildings. Next slide. More definitions. New terminology is introduced. Controlled drainage is a new term, which means drainage from balcony that prevents water ingress to the interior and staining of the exterior of a building and nuisance to persons under or around the balcony or damage to the landscape below. There are various other terms used for controlled drainage, but it was felt that controlled drainage was the most succinct and explanatory term here. Next slide. It talks quite a bit about edge drainage. There's a lot of discussion in the industry about should balconies or can balconies be drained off the edge of the balcony. This gives rise to potential problems if the design is not properly and carefully undertaken, and so the matter of edge drainage is discussed in some detail in order to prevent those problems, and a definition is given: drainage of water collecting surface via the edge of a balcony. Next slide, please. Other new terms: principal water collecting surface is a new term that is coined for various reasons that will become apparent later on in the presentation when we start talking about drainage and water management and hydraulics. Ingress level is another new term, which is the point at which water will, if backed up on a terrace, will enter the building, and is a critical datum or line that needs to be considered in the design, particularly of terraces, but balconies also. Juliet guarding is another term that's introduced. This arose because of the use of Juliet balcony is common terminology, and we looked at what a Juliet balcony is, and it didn't really fulfill the terms of a balcony, and so the standard refers to something to a more accurate definition of the function of that entity and calls it a Juliet guarding. Weather screen, of course, is another term that's used in enclosed balconies. Next slide, please. So there's a slightly helpful diagram of a hideous building. This is the archetypal Frankenstein building, designed by committee. It basically started off as a simple building and kind of grew with various protuberances to illustrate all the various features within the definition. So let's have a look at that closely in the next slide. The first four. There's the key. If we carry on to the next slide, we will see the first four types of entity, which are the projecting open balcony, the projecting enclosed balcony, the recessed open balcony, and the recessed enclosed balcony, illustrated there for clarity. The next slide has the next three, which are terrace, recessed open terrace, and recessed enclosed terrace. So if you look at number 5, that's deemed to be a terrace in terms of the text within the standard. Number 6 is an interesting one because some people would call number 6 a balcony. Again, having written the definitions of balcony and terrace, we looked at number 6 and 7 and deemed it not to be a balcony as such, but more akin to the function of a terrace because it performs the function of a roof. It's over an enclosed space, an occupied space below, an interior space below. So therefore, the standard deems it a terrace rather than a balcony, one being enclosed and one being open. Next slide, please. So here's a illustration of the concept of Juliet guarding. Again, standard having defined balcony could not really call these Juliet balconies and therefore coins the term Juliet guarding. Next slide, please. And finally, access balcony and access terrace. Notice the subtle differences and these two. One is a balcony, one is a terrace. 9's a balcony, 10's a terrace. And notice the differences in the guardings, which are basically derived from BS 9991 and the provisions within that standard. Next slide, please. That. And then finally, there is the illustrations of the different types of guarding and also, quite crucially, ways of reducing fire spread across terraces and along terraces. And one way is to introduce the concept of a performance standard, BROOF T4, which is a reaction to fire standard listed within EN 13501 as a way of preventing fire spread across facades. And Tony will is going to elaborate on this in the fire section later on. Thank you. So next we've got Andrew Parsons, who will cover structural and mechanical stability.
Thank you, Mark. Trust you can hear me. Andrew Parsons, I'm the Technical Director for Sapphire Balconies. We're one of the leading balcony suppliers in the UK and also a bit of a global outreach as well. Got over 40 years experience in the construction industry. So on the next slide shows the agenda. The parts we're covering: structural, mechanical stability, and then a section about integrity and safety, and that's broken down still further, as you can see on that contents page. So if we move on, we start with the typical types of balconies and the fixing methods. Over the last decade or so, we've seen quite a marked change in the typical construction of balconies. Traditionally, there's been a concrete extension of the concrete slab, and while that still is used today, there's various moves which have meant that a lot of balconies have moved away from that. There's been the increase in the thermal and the acoustic flanking regulations. There's also a move towards DFMA, the design for manufacture and assembly off-site, which has been led by the changes in the industry and availability of labour and so on, and also a move towards increased emphasis on quality, which is more easily obtainable in a factory environment. So what that's brought to rise is a range of off-site manufactured balconies, which are supported either conventionally from the main structure of the building or also integrated into the facade. So if we move on, there's just a few slides here showing some of the different types of balconies that we're talking about, just to help people understand them. Most common is probably the projecting balcony, typically rectangular but can be shaped, and as you can see there, with a whole range of different balustrades, which we'll talk about during the presentation. The sizes of those obviously are often determined by the London Housing Guide, so typically from 3 to 9 meters. The next slide shows an inset balcony there in the middle on the left slide, which Mark touched on earlier. They have quite different regulations covering those, and different fire and wind protection regulations. On the right there, you see a corner balcony. They're particularly susceptible to wind loadings, which I think will be talked about in more detail later on in the presentation. If we can move on, please. There's what we know as the inset balcony, where the balcony is inset into the structure. Traditionally, these walls expected to have positive drainage, but there is a lot of move towards using controlled drainage for these as well. Actually, they're protecting the building behind them rather than giving any further cause to water ingress, and providing pattern staining is avoided by keeping the water outflow away from the adjacent wall surfaces. They can be very effectively controlled drainage. The right-hand picture there shows another type of inset balcony between projecting fins, which is becoming increasingly common. The next slide shows more fin wall balconies, increasingly common, especially since the whole uncertainty about laminated glass and the need for more move towards vertical bar balustrading for the front to allow light into the building, but the use of solid walls, either full height like you see here or part height, does give a degree of protection from the weather. So if we move on, we mentioned balconies connected to the structure. There's also a move, especially with some of the modern methods of construction, towards supporting the balconies off the facade. The advantage here, of course, is that the connection loads are significantly reduced, and that is more relevant for modern methods of construction. So if we move on to a bit more detail about the calculation for strength and deflection. One common complaint in the past has been that balconies are bouncy, and there's been very little real guidance as to how to control that. You look in some standards and they say L/180 for cantilever, which may be all right in some circumstances, but certainly is not generally acceptable for balconies. So what this guidance does is it raises the bar and sets a standard that as a minimum that they recommend people achieve. We could have said at L/360 deflection limit, but actually what's more readable by balcony users is actually the vertical amount of vertical movement you get under a given load. Now 2 kilonewton is the load, concentrated load, which is stipulated in Eurocode, and so we decided as a committee that 5 millimeters was an absolute minimum, that, or maximum I should say, that deflect under that load. What it gives is something that's easy to be checked on site. There's also mention about a natural frequency limitation of 5 Hertz. Again, on this one, the larger the number, the better the balcony is. Now, frequency is is important, but it's a good servant, but a poor master. It's very difficult actually to check the frequency of a finished balcony. So the empirical deflection limit, we feel is more appropriate. Thank you. Move on. So the rise of modern methods of construction has brought the need for a whole range of new fixing methods suitable for those methods of construction that can incorporate the need for water tightness, increased requirements for thermal and fire integrity of these connections. There's not one size fits all solution. There are so many different methods of construction coming out. You can see here like edge steel frame, the unitised cladding, as well as the conventional pour. The next slide, please, shows a number of other options. You've got there concrete wall panels, you've got modular construction coming out, CLT, not used much in this country now, but still very relevant in Canada and places like that. So there's a whole range of connection details that need to be developed. The next slide confirms that all designs should be to Eurocode. And the particular importance of this is the loadings that's required, because the old 6399, which some people still use for some designs, only requires 1.5 kilonewton per square meter as a uniformly distributed load, whereas Eurocode sets a minimum of 2.5 for single residences, and it's important that guidance of Eurocode is followed implicitly. There's also reference there, you can see, to BS 6180, which is still the governing document for the barriers and would cover the Juliet loadings that Mark referred to earlier. I think it's under revision, but it's still it's an old document, but it's still very relevant. So just moving on to a bit more about deflections. The designer needs to be conscious that there's a number of areas which cause deflection. There's the dead and live loads on the balcony itself, but there's also the potential of movement from the thermal break area, and even from the substrate itself. The slab can deflect, particularly with the move towards thinner post-tension slabs and so on, and as we said earlier, modern methods of construction. So need to take all of that detail into account when considering deflections. Next slide. Thankfully, we've got a lot of very powerful tools available to us these days in the way of finite element analysis and modelling, and this helps greatly not only in predicting deflections under various loads, but also useful for predicting the thermal effects, and the standard actually refers to that, the need for three-dimensional modelling of the areas around the penetrations to the building. So moving on now to a little bit about safety and how the standard addresses that. There's a number of areas here. The first one I want to touch on the next slide is the safe installation of balconies. So next slide, please. Yeah, the guide covers and recognises the risks of installing the balcony and the need to go to whatever lengths are possible to avoid people working at heights, and also it touches on the common practice of working underneath a live load and the dangers of that. So I think balcony designers need to be cognizant of their responsibility to design their balconies and connections for a safe installation. The next slide touches on the safe maintenance of the balcony. the CDM regs, that's also the designer's responsibility to ensure that any maintenance, both of the balcony and of the adjacent wall panelling, can be carried out safely, and there's adequate strength in the design to enable that to happen safely. There's also consideration of the end-of-life disposal and the need for the environmental effects to be considered from cradle to grave of the balconies. Further on, next slide touches on the advantage of soffits on all balconies, and the British standard encourages the use of soffits. Not only is there an aesthetic benefit, but particularly it helps safety in use because it prevents people dropping hot liquids onto the residents below and causing damage in that way. And it also brings an increased safety in fire because it's been can be demonstrated that soffits help prevent burning debris falling from one balcony to another, and actually help in the prevention of the spread of fire in a number of ways. The next slide shows the dangers of ensuring that residents are aware of the safe working load of their balconies. As I mentioned earlier, some balconies in the past will have been designed to 1.5 kilonewton square metre. The current minimum requirement in the UK is 2.5 kilonewton, and elsewhere we deal with designing projects in Canada, for instance, where the safe working load is deemed to be 4.8 kilonewtons per square metre. So it's important to be able to convey that information to the residents as a minimum in the owner manuals, and making sure that that's pointed on to the residents. What the standard recommends, and something I think the industry needs to move towards, is some sort of sign or something that you have, like you would have in a heavy passenger lift that you go on, which gives them some comfort that they're working within the prescribed limits. These pictures show a couple of areas where balcony is definitely being abused. It's certainly not a place to put a hot tub or a paddling pool, but that's one of the dangers that it does have. And the next slide goes over, the standard goes over in quite detail, again referring back to other standards, the requirements for minimum balustrade heights. It can be boiled down quite simply to the fact that 1100 balustrade is a minimum requirement in all cases, but where there's a step adjacent to the balustrade or anything that's climbable on that is between 400 mm and 600 mm, the recommendation is the balustrade should be 700 mm above that step. So that's clarified. It also gives recommendations for the need for a small plinth where you've got a vertical bar balustrading. It's not something that's been defined before, but it gives guidance as to how to calculate the minimum height of that kicker plate adjacent to the balustrading. Moving on, just a bit about one of the questions that came up prior to the meeting was about testing of balconies. We've already touched on the advisability of being able to test the deflection of a balcony. That's an easy way of ensuring that it's coming up to standard. But a lot of the Eurocodes do actually allow for design assisted by testing, which is very useful when considering some of the modern methods of building balconies. We'd all be familiar with the wind rain tests, which help test the water tightness of the building, and also there's often a requirement for impact testing where there's a cradle or BMU being used on the building to make sure that should that fall out of control or become blown about by the wind, that it's not going to cause any parts of the balcony to fall off. The next slide touches on the requirements of the British standard to ensure that the service life, not only of the main structure of the building, which is often typically 50 or 60 years these days, but also for component parts of the building. It does make mention to the balustrading, infill panels, and also for the pedestrian surface, and the possibility that that might be able to have a 30-year life. But even so, I think the designer's got responsibility to ensure that that could be replaced both safely and effectively, and that there's a method statement considered for that. The next slide touches on a point in the standard about the effect of wind uplift on paving or materials used for the balcony. It's often disregarded, but there are studies available which show the vulnerability of floor materials to become dislodged in very high winds, and the need to give some physical restraint for those. The next slide touches on thermal breaks and the efficacy of those. As many would know, thermal breaks serve two specific purposes. One is to minimise heat loss, and their standards are being raised all the time for what is needed, especially with the advent of passive house and other high standards, but also to minimise the risk of condensation forming within the building. So important that they're designed correctly, and as I mentioned earlier, that make sure that there's no movement, they don't introduce excess movement to the balcony itself. Last but not least, the balcony standard touches on slip resistance, and there it gives some quite clear guidance as to not only the amount of resistance that is to be expected, but also even the type of rubber that's to be used in that test. These things weren't too clear before, so hopefully that guidance is useful. It touches on the need for cleaning, potentially to maintain that slip resistance throughout the service life of the balcony. And it also touches on slips, trips and falls. So we've got a maximum 3mm step in the decking, and a maximum 8mm slot or 10mm diameter hole, again in the decking. So hopefully that's been a helpful insight into both the structural and the safety parts of the standard, and if there are any questions we put in the chat. Thank you.
Oh, good morning. My name is Jane Simpson. I'm an architect and an access consultant, and I've been involved in the development of this particular standard. What I want to do is set the scene with regard to inclusion, explaining the relationship with regulation and legislation, set the context of other material factors, and move on to how this may impact on the design and detailing of balconies. We have the legislation, in particular the Equality Act, which is largely concerned with access to goods and services. We have different regulatory standards within the UK, so Northern Ireland, Wales and Scotland are slightly different than England, but within England we have the ADM, K and B. But I would say that the actual standards are fairly similar, regulations throughout the UK. Building regulations have a number of elements applicable to this standard. The Equality Act does not impact generally on residential accommodation. However, Regulation ADM Volume 2 identifies that ADM Volume 2 does apply to common or public areas of residential developments. The Equality Act will be applicable to those areas within residential complexes and public buildings. What is important to comprehend is that ADM Volume 2 clearly states that meeting ADM does not necessarily constitute meeting the obligations of the equality legislation. There will also be planning conditions, particularly in relation to the categories in ADM Volume 1. Volume 1, categories 1, 2 and 3. Again, these are England-based. You will have different regulations in the rest of the UK. Furthermore, some grants may require varying standards. So you need to keep all of these things in mind. So for example, Sport England has different door widths. Next slide, please. Can I have the next? Thank you. So down to the detail. Following the guidance, 9.1 is thresholds. They should be level. There will, of course, be issues around air tightness, acoustics, and water ingress. The recommendation in the standard is for no more than 15 mm high with a rounded profile. The photo bottom right is of a scheme back in 2014, which was almost there. If the threshold itself is not 15 mm or less, then guidance is given on how this can be locally amended, such as sloped surfaces. For example, it also advises that in these cases, the approach should be straight on. So please read, it's only quite a small section, but if you read the section, you get a bit more guidance on how to deal with thresholds. However, there are companies developing thresholds that will deal with this, so keep your eyes peeled. This one is Shuko. It has a liftable seal bar and can achieve the necessary air and water exclusion requirements at the normal test pressure of 600 pascals. So what I'm saying is product manufacturers will start to move forward. Next slide, please. So dimensions. Generally, doors open inwards to reduce the negative and positive wind pressures. Note this also improves the access to the terrace or balcony, but may impact on internal circulation. The standard recommends a minimum of 1500 mm turning circle on the balcony, but as can be seen from figure G2 from BS 8300 part 2, a turning circle of 1500 may not be sufficient. 90% of electric wheelchairs could need a space of 275 mm long by 1625 wide. That's quite a big space. The opening and closing force required should be no more than 30 newtons. Under regulations, this is the same for public areas, and it varies for residential zones and between the different categories. So you need to spot exactly which ones you need to adhere to. But you can also see BS 6375 for more information on opening forces. The doors themselves should be treated in terms of width as you would do for any door. And note, this can vary for different locations, as I mentioned earlier, with particularly Sport England. So please check the relevant guidance. One area that is important to get right is the clear leading and following edges. This standard requires 300 mm on the pull side and the door to be located no deeper than within a 200 mm recess. However, when considering housing in ADM, there is a requirement for clear leading and following edges. See at diagram 3.2, which is just on there. The BS 8300 part 2 requests 300 mm to both sides, but recommends 600 mm on the pull side wherever possible. When considering sliding doors, there's little information available. BS 8300 has gone some way to clarifying this by asking for 300 mm leading edge to both sides for sliding doors. I will also say that there are lots of other sectors. So, for instance, hospitals, again, will have different requirements for leading and following edges. So please look at each one in each circumstance. Next slide, please. So in terms of details, there are two sections, surfaces and sightlines. Guidance is provided on surfaces. It does ask that any surface should be such that it does not allow entrapment of a wheelchair or stick for high heels. For example, any slot should be no more than 8 mm wide and set at right angles to the dominant line of travel. If circular holes are used, they should be no more than 10 mm in diameter. Where an exterior view is offered through a fully glazed window or door, the view through the balcony should not be obscured, i.e. when someone is sitting, brackets wheelchair user. The standard requires that 50% of the view is maintained. Balustrades or glazing may be used. On the slide, there are 3 different balconies which have very different treatments, all of them providing vision. And that was quite a short section. And now I'll move on to Tony Hall, who will cover performance and fire.
Thank you. So my name is Tony Hall. I'm Technical Design Director of Levitt Bernstein. We are architects who design a variety of different building types, but are perhaps best known for our residential experience. Next slide, please. So I personally have been involved with many thousands of balconies in my experience. So therefore, I've been asked to participate in the drafting committee of this new standard. So why does the new standard include a section on performance in fire? Next slide, please. There are existing guidance such as BS 9991, BS 9999, and building regulations. So why do you need to add more guidance? The standard aims to resolve anomalies or conflicts in the current guidance, provide clarity or guidance where there isn't any, and it should also be remembered that the Hackett report into the Grenfell tragedy stated that there was a problem with existing guidance being confusing and hard to follow. This standard seeks to address this. It must also be remembered that in the hierarchy of the regulatory environment, that the requirements of the building regulations have more weight than this British standard. Next, please. So why can't we just use Regulation 7.2? Well, there's a couple of reasons. Next. Firstly, balconies are specified attachments under Regulation 7.2, but are terraces. Does Regulation 7.2 apply to terraces? This is not very clear in the current regulations. There are also ambiguities that need clarification. We should also remember that this is a British standard and used throughout the UK and worldwide, whereas Regulation 7 is a national regulation that does not necessarily apply to Scotland or Northern Ireland. Next. So during the period when the guidance was being drafted, there were several outside events that occurred. Next. Firstly, there were changes to Approved Document B and Regulation 7 that were published during the drafting period, as well as consultation into wider amendments to ADB. Secondly, there's also some high-profile fires that were widely reported, such as the Bolton Cube building. The fire report identified a discarded cigarette as the probable cause of this quite horrible fire. Next. There's also the Barking Riverside fire, which spread rapidly over the balconies. The balcony was constructed of combustible materials. It was a particular set of circumstances that caused the fire and its rapid spread, but even so, it was a pretty horrific fire. Next. So what are the key issues identified in the standard? So there are 4 key requirements. First of all, the components of balconies, terraces and walkways when exposed to fire, including from below, e.g. from a window or other openings, should A, not be composed of materials designed such that they provide medium for undue fire spread over the external envelope of the building, that they should not propagate fire downwards, i.e. produce flaming brands or molten droplets from debris that could cause a fire below. Next, they should be designed to minimise the risk of becoming detached from the face of the building and present a hazard to persons below, i.e. firefighters or the public. And finally, they should be designed to minimise the risk of prejudicing the stability of the building when undergoing large deformations resulting from fire exposure. The guide goes into further detail to explain what this means, and I will now discuss that in detail. So BS 8579 sets out guidance for enclosed balconies and terraces, as you will see in Figure 2. Next. The guidance sets out the need to consider fire separation, both horizontally and vertically, between enclosed balconies. If you go to the next slide, you will note that in Figure 2, the lines of fire separation extend all the way to the edges of the balcony. It should also be noted that the floor of an enclosed balcony should provide fire separation from a balcony below in accordance with BS 9991. Where such a floor is penetrated, for example by a drainage outlet, then provision should be made to ensure continuity of the fire separation by using the fire collars where the pipe penetrates the slab. Next. I will now turn in more detail to what the standard includes for materials and components for balconies with respect to fire performance. So, to prevent fire spread across a building, the guidance recommends the use of non-combustible materials. It describes the following fire performance. As you will see, it talks about requirement to be class A1 or A2 S1 D0 in accordance with BS EN 13501 Part 1. There are exemptions to this, which we'll come to in a minute. Next slide, please. Now, you will note the need for non-combustible materials starts at 11 meters, or if the balconies are stacked, any height of building. This photograph shows balconies in a stacked arrangement. Although they are staggered, they still overlap in plan and therefore could be considered as stacked. Next. There have been incidents when burning droplets from a balcony above has caused the spread of fire. The prevention of this is one of the key requirements in the standard. Next. So this tray can also protect the balcony from below, i.e. from a fire breaking out from a window or other opening that's directly below the balcony. So therefore, balconies with an open structure and open pedestrian surface should be fitted with a non-combustible imperforate tray or soffit to reduce the risk of fire spread into balconies and adjacent internal areas. The tray can act as a water collecting surface, and as can be seen in this photograph, a visual soffit to the balcony. Next, please. In the standard, it makes it clear that terraces are not balconies. The relationship with adjoining buildings is different, and so their performance in fire needs to be assessed differently. There is a fire risk of spread of fire across a terrace that may pose a risk to the building. The guidance fills a gap in the current regulations to show how a terrace should be treated when it's adjacent to a building. Firstly, it addresses the performance of the floor surface. The terrace, being an occupied floor, performs the function of a floor, and therefore terrace or an access terrace should be limited to classification B roof T4 in accordance with BSEN 13501 Part 5. Next, please. So again, the key part of this paragraph is over 11 meters and within 3 meters of a facade. Alternatively, if the terrace is planted, it can be broken up with fire-resisting walls or strips, such as paving, that achieve minimum classification of B roof T4. It is also worth noting that in BS 8579, it provides further guidance on how B roof T4 can be achieved using paving slabs, as it is not quite as straightforward as set out in the deemed to comply Commission Decision 2000-553 EC. Now, turning to guarding. Next slide, please. Again, the fire performance of terrace guarding is not enshrined in current regulations. The risk of fire spread adjacent to a building is mitigated in the guidance, as it calls for terrace guarding to be constructed from materials to class A1 or A2 S1 D0 in accordance with BSEN 13501 Part 1. Again, note it starts within 3 meters of an extensive vertical facade and an occupied floor over 11 meters above the lowest ground level. Next, please. There's been much discussion in the industry of the use of laminated glass in relation to its performance in fire. Laminated glass is quite often used as balustrading, as it offers many advantages, such as allowing daylight and views through, giving protection against wind, and also provides an imperforate balustrade to access decks in accordance with BS 9991. Next. According to Regulation 7.2, as a specified attachment, a balcony needs to be mainly constructed of non-combustible materials, i.e. A1 or A2 S1 D0. Now, there is a list of materials that are classified as A1 in the EU Commission Decision 96/603 EC, and laminated glass is included in that list. However, if you go on to the next slide, you'll note that it says that none of the materials in the table is allowed to contain more than 1% by weight or volume of homogeneously distributed organic material. Laminated glass includes an interlayer which would be greater than 1%, so technically would not be allowed to be classified as A1. Clearly, this has led to confusion. So the question that needs to be asked is the use of laminated glass in balcony or terrace garden a contributory risk to the spread of fire over facade? Next. The guide seeks to address this issue. Next, please. In the section on both balcony and terrace materials, there's mention that if it's not possible to use materials of at least class A1 or A2 S1D0, then minor components could be exempt from this recommendation if an assessment of the risks proves adequate resistance to the spread of fire is maintained. This includes seals, gaskets, fixing membranes, including roof waterproof membranes, laminated glass and thermal breaks. Next, please. It does go on to note that attention is drawn to national regulations regarding the use of certain components, such as laminated glass. Next, please. Now, this is clearly a major issue at the moment, with lots of debate over it. Further research and testing is required to establish the performance of laminated glass. This is being looked at by national government as well. There are manufacturers who are currently carrying out research, and the results will be eagerly waited. Next. I'm now going to pass you over to John Purser. So thank you for listening. John?
Thanks, Tony. I'm John Purser. I've spent about 40 years involved in the design and manufacture of drainage outlets, including those for balconies, terraces and roofs. And these are all detailed in EN 1253 Part 1. There's been, as we've heard in recent years, an increased demand for balconies, bringing with it the need to remove rainwater as it accumulates. I'd hoped to find a scene of post-rainfall devastation on a balcony, complete with floating sun loungers, but it's reassuring that my peer group and I can't find anything that dramatic. It rarely happens in my experience, and then only because of cost cutting during construction. And this standard is covering the very wide range of designs, which you'll have seen is designed to make sure that doesn't happen. In sections 15.1 and 15.2 of the standard, drainage of balconies and small terraces, we state the design of balconies should incorporate some form of controlled drainage to prevent water ingress into the building, unsightly detrimental staining of the building and or nuisance to people or damage to landscaping below. And there are two generic methods of draining a balcony or a small terrace in a controlled way. Edge drainage, where water is collected on a surface and directed to an edge where it is thrown clear of the building, and pipe drainage, where it's collected on the surface, including at the edge, and directed via gutters and or outlets to pipes in the building drainage system. And as Mark detailed in his introduction, keeping the water away from the door back into the building proper is a very, very important point. An understanding of how rainwater affects a balcony and its surrounds is essential for good design, and the following should be taken into account. Incident rain, there's the influence of balconies above, flanking walls, imperforate guardings, uplift and eddy-borne rain. And for small balconies, this usually means that precipitation is not a problem. Most balconies benefit from the sheltering effect of balustrading and or the balcony above. So it would take literally a lot of horizontal rain to cause some meaningful effect. Next slide, please. And this gives an indication of the catchment area that should be used in the calculation of how much water might end up to need to be got rid of. Rainfall outlet design with an adequate width of the waterproofing flange is detailed in BS1 EN 1253, and that of course it's key to make sure that the waterproofing layer, and we've discovered that it can be in two places. It could be in two places. It can be on the top of on the walking surface, or it can be beneath. It's important that that drain outlet is completely weatherproofed into it, and the overflow design, location, discharge clearance, and their location is essential to for the prevention of residual dripping. Next slide, please. And a great deal, you can see that there's been a great deal of detail put into this to make sure that the drainage options all slope away from the door or into a drainage outlet. It's also important to consider cumulative flow and downpipe design if water from one balcony is drained down onto another balcony and collecting water from that on the way to its journey under gravity down to ground level. That's frequently encountered. And furthermore, the warning pipe design, next slide please. This again shows some of the detailing available in the standard of how to do it properly and to make sure that the threshold design, the freeboard, and prevention of water ingress at openings can be achieved. Those are the principles of the strategy that we employed to create some advice for detailed design, and I hope that they will be useful. Thank you.
Thank you, John. Hi, everybody. I'm Dan Hackett. I am a practice area leader at RWDI. We are a global company of consulting engineers and scientists who specialize in all those ways in which the natural environment interacts with the built environment. And it's my great pleasure to talk briefly about how wind effects are captured in the new standard. Next slide, please. So, by way of introduction to the topic, here are a few of the main factors that we need to be concerned about in design. These are the things that would cause the wind speed to increase as it blows around our buildings and consequently increase the severity of any impacts from that wind. Notably, height above the ground, wind is often a significant issue for very tall buildings, but by no means limited to that. Exposure to the prevailing wind direction, and especially in the case of building corners around which you often find some of the greatest accelerations. And then also the proximity and arrangement of all the other buildings around it that give rise to all sorts of effects, which we might refer to as channeling or funneling of the winds. Often you have recirculation of wind in the wake of a building. All these things are things that we should be aware of and potentially concerned about as we're designing the building. Next slide, please. So one of the important effects that we need to consider is obviously the wind's impact on the structure and cladding of the building. And this is a topic that is covered to some extent in the Eurocode on wind actions and the associated national annex. But it doesn't have an awful lot to say about balconies and terraces or balcony guardings. And the reason this is a distinct design issue is that when you look at a balcony guarding, you can easily imagine that the wind is having an effect on both the front and back surfaces of that element compared to the main facade of the building, in which you have on one side a relatively stable and predictable interior pressure environment, and you only consider the dynamic effect of the wind really on the outer face. Next slide, please. So the standard has this to offer, and it is for limited cases of relatively conventional buildings up to 50 meters in height. You can assume a net pressure coefficient of 1.8 up near the roof of the building and near the corners, and 1.5 mid-face. And this guidance actually appears in the wind loading handbook for Australia and New Zealand, which is quite thorough and happens to be the most helpful and most relevant guidance for us here. Outside of this limited scope for taller buildings or unconventional shapes, the standard recommends testing in the wind tunnel, measuring those pressures on the guardings, which can vary quite substantially across a building. Next slide, please. The other key wind effect that we need to be concerned about and that is covered in the standard is microclimate, by which I mean the local acceleration and deceleration of the wind with respect to people, occupants of those areas. This can mean the difference between a balcony or terrace that is very comfortable and pleasant, and one which is essentially unusable due to the wind. In extreme cases, maybe even unsafe. All the factors we previously described, height, exposure to prevailing winds, are all still relevant here as well. And I would point again specifically to proximity to building corners as being a key factor here. There are, of course, some good design reasons why you might want to have a balcony at the corner of a building, but it can be a figurative red flag for wind because of how the wind wants to accelerate right in that area. Next slide, please. So the standard offers a few good design tips, a few additions that you can consider making to improve the microclimate on balconies and terraces. They're shown here as well. Increasing the height of guarding, 1.5 meter high, gives you plenty of shelter then to someone sitting on that balcony, such that they're completely sheltered from the wind. You may want to keep the front guarding at a lower height, but you can improve comfort for the occupants by introducing side screens, which block the wind as it tries to blow laterally across the surface of the building. Or for larger balconies and terraces, consider introducing dividers to those spaces. Again, of course, there's always a balance and a compromise in design. There are lots of desirable reasons for having a large open terrace, but if wind is an issue, it is helpful to split that space up into smaller, more sheltered pockets. Of course, with any of these sort of measures, oh, sorry, can we go back a slide, please? Thank you. With any of these measures, if you're increasing the surface area of the guarding, you have to consider the knock-on effect in terms of the wind loads on that increased area. All of this can potentially be assessed and quantified using, for example, wind tunnel testing or computational modeling. There are good reasons for doing those things in terms of optimizing these spaces for wind comfort and safety. Depending on where the building is being built, you may be compelled to do that sort of assessment anyway as part of adhering to local planning policies with regard to environmental impacts. So if the opportunity is there anyway, or the necessity is there anyway, you can take that opportunity to assess balconies and terraces in the same way. Next slide, please. Just a final note from me with regard to wind. Clearly, if the wind speed is such that it could make people uncomfortable on this balcony, then it may also cause objects or furniture to move around in high winds. The difference between that and the human occupants is that these objects or furniture may well be outside there in all weather. Simple solution and one to consider is including tie-down points such that occupants could secure their own objects on the balcony. Just in summary, wind, it's complex, it sometimes acts in ways that are difficult to predict. The guidance that is presented in the standard is a useful starting point for larger builds, more complex builds. More specific advice could be gained from an experienced wind consultant. Mark, thank you very much. Back to you.
Thanks, Dan. I'm just going to round off by covering thermal, acoustic, and security considerations. Firstly, thermal. Next slide. Thank you. So obviously, the inclusion of balconies and terraces means there are junctions, there are connections, there are penetrations through the thermal line. We've talked earlier on about where that thermal line is in terms of the definitions of the standard. And so some work needs to be done on assessing heat flow and particularly heat loss in order to comply with national regulations and in order to keep the building as energy efficient as possible and maintain comfort and prevent the formation of interstitial and surface condensation. So firstly, one-dimensional heat flow needs to be assessed through the plane surfaces such as terrace decks, the adjacent walls and any soffits. That implies that there will be junctions and that requires two-dimensional heat flow. And of course, where brackets penetrate through, three-dimensional heat flow it needs to be calculated as well. Where the brackets penetrate, there is, and also where balconies abut against the internal elements, obviously there is a need for thermal breaks. Those thermal breaks may have to be acting as or in conjunction with fire stopping or cavity barriers. There is guidance within the standard about that. I'm not going to cover it in detail here, but there's plenty of information about that. Next slide is about the acoustic guidance. There is quite a lot of acoustic guidance. I'm not going to cover it. It's not my expertise subject, but in essence, the standard points out that the inclusion of balconies particularly has effects on building acoustics. in that they could actually mitigate or accentuate external sound sources from when perceived from the inside by the reflecting surfaces that are on the underside of balconies, potentially reflecting into a room, or it could provide shelter by virtue of the fact that it that actually the surface of the balcony or the guardings actually reduce the sound pressure by virtue of the fact they're there. So it's worth considering each situation, and then the standard does offer ways of mitigating those effects if they are accentuating effects by putting additional absorptive surfaces, or by the geometry of the building, the geometry of the balconies, and just analysing, employing the acoustician to do the analysis of the impact from the sound source via the balcony and the changes in geometry, etc., on the interior space. So plenty of guidance on that within the standard. And there is also guidance on security measures that should be included for good balconies and terraces. So that's us pretty well completed. Thank you very much for listening. And I think we'll now go over to Akimi Ho, who's the concept manager for the standard, who basically kept a panel of, I don't know, between 25 and 30 people in check, managed us all, and organised everything. So thank you very much, and back to Akimi.
Hi everyone, so I'm just going to be asking some questions that have been sent in. Thanks for sending in your questions. Some of them have already been answered in the presentations that our panelists have given, so I'll just ask a couple, as many as time allows, and I'll go to the relevant panelists for an answer. So the first question we've got, I don't think we've covered yet, is how should the issues of overlooking and privacy to neighbours be addressed? And that's a question for Mark.
Thanks, Akimi. Okay, so this, I guess, we need to think about what are our expectations for privacy in a private amenity space. Terraces may not be private amenity spaces. They may be part of, or there may be private amenity spaces on terraces, or they may be shared amenity spaces. Balconies tend to be more private amenity spaces, and there is an expectation of some privacy. However, you know, when you think about a domestic, you know, a suburban residential garden, there is no guarantee of complete privacy there. So that's always going to be the case with balconies. So the standard doesn't really comment much about privacy too much. It does encourage the designer to consider privacy and to enhance privacy and suggest the use of partitions. There's a discussion of solid versus transparent, and also in that discussion of solid versus transparent in the guardings, in the design of the guardings, designers need to consider inclusivity. As Jane mentioned, the percentages of transparent zone that really should be included to allow you know, permanently seated people such as wheelchair users to enjoy views out, rather than just being blocked by a solid guarding. So I think that pretty well covers privacy.
Great, thank you, Mark. Our next question is on a couple on fire, so I'm going to go to Tony on this. What is the fire protection guidance for elements of structure supporting balconies? I've already covered some of this.
The standard refers out to BS 9901 and BS 999 for that requirement. It doesn't add anything further to that, apart from a commentary that the designer should consider the effects of the deformation of the balcony on the building, and to minimise the risk of the balcony becoming detached in the event of a fire. But apart from that, in terms of the actual fire performance of the the structure itself, it refers out to 9991 and 9999.
Great, thanks for clarifying, Tony. And what guidance is given regarding the materials used for the balcony floor and wall finishes, including pedestal systems for flooring?
In terms of the materials for the floor, they should be A1 or A2 S1T0. It does mention that minor components can be exempt if you carry a risk assessment that can determine that adequate resistance of fire spread can be achieved with those less performing components. There aren't really any additional requirements regarding adjacent wall performance, except in the case for a recessed balcony, which is adjacent to another fire compartment or dwelling. In this case, then the wall is also considered as a fire compartment wall and needs to meet the relevant fire performance for the building. There is also reference to fire stopping at the junction of balcony and adjacent wall, but nothing else on the wall surface itself.
Great, thank you, Tony. Our next question is about glass. So what is the guidance for using laminated glass versus toughened glass? I'm going to go to Mark for that.
Thanks, Akimi. Right, so this is part of a wider discussion about laminated glass, but I think the quick answer to that is refer to BS 6180. We thought that the right place for this type of information would be within 6180 rather than 8579. And we understand that 6180 is under review at the moment for another iteration, an update. So I think that's where the discussion of one versus the other really needs to sit. I think this is probably a question about post-breakage containment, how much, you may ask the question, how much post-breakage containment is appropriate. The standard doesn't address that. I think it does mention the need for consideration and also probably the need for thermal shock, things like that, but refers out to 6180. So I think the thing to do here is to watch where 6180 goes. I think you know this standard 8579 basically points the designer to consider these things, but doesn't necessarily provide all the answers within this standard. Thanks, Kimmy.
Thanks, Mark. Another question on glass, actually. Can laminated glass be used in glass balustrades?
Right. Okay. So I think this is one of the most popular questions. We certainly got a lot of feedback during public consultation about this. The panel we felt we had to consider the matter of laminated glass because there was so much questioning going on around the industry, so many people talking about it, so much uncertainty and so on and so forth, and it was actually a difficult task to know which direction to go in, because various people have various different views, so on and so forth. The thing to remember is the standard is actually only a guide. It is a guide to design. It isn't a code of practice or anything like that. So it's basically a guide. Excuse me. So why use glass? I think Tony made reference, and probably Andrew as well, made reference to why we would need to use glass on balconies and terraces, and the social benefits, the wind buffering benefits with the inclusivity benefits that Jane talked about. So it was felt there was a role for glass in balconies and terraces. Why use laminated glass? Well, safety is the obvious answer to that. You know, in some countries, laminated glass is mandatory. On balconies in the UK, that's not necessarily the case. Designers need to consider the risk of injury and death from falling from a post-breakage scenario of a broken non-laminated guarding versus any risks arising from fire. Tony's already talked about the vaguenesses of the legality, the legal case in England with regards to Regulation 7, the wording of Regulation 7, the European Commission decision, the wording in that. And of course, obviously, different building types in respective building Regulation 7 only covers certain building types. There is always the overriding consideration of requirement B4 in England, which is the requirement to ensure fire safety, which almost goes unclassified in some respects. Added to that is the question of whether laminated glass is combustible. As such, the jury's out on that, I think. Is the interlayer combustible? Yes, certainly certain types of interlayers are combustible. PVB is known to be combustible, but there are other interlayers. There is research into the use of other interlayers going on around industry. The government's commissioned its research, so hopefully over the course of those two parallel activities, further guidance will come out. I think there's a need for a test standard for balconies for fire spread across balconies, in particular in respect of laminated glass, because none of the tests available at the moment, 8414, etc., are not really relevant to fire spread via a balcony. So I think there's a need to understand how fire progresses across balconies and to qualify the threat to life and property. So I don't think there's an absolute answer to that one yet, and I think it will all be borne out in the course of time. The standard, of course, as Tony has highlighted, tries to remain neutral in that it does say that in terms of laminated glass, these could be exempt from the recommendations within the standard if an assessment of risk proves adequate resistance to the spread of fire is maintained, and also draws attention to national regulations. So I think that's basically it in terms of laminated glass.
Great, thanks, Mark. I'm aware it's 11:30, so we haven't got through all the questions that we wanted, but that's simple as to whether we need to close the webinar for now. So Mark, I'll hand back to you. Thank you very much.
Well, thank you very much. Thank you very much for everybody joining in and listening. It was as I say, several years of work went into the writing the standard, and a lot of people have contributed. So gratitude to all those who put major contributions in, and thank you all for listening, and we hope that this standard will help industry clarify certain things and make us a better industry, able to produce and provide better balconies and terraces for our cities. Thank you.